Now see here, this is the graph for the actually cooling of the water. If you have taken the water in a container and it is allowed to cool. So, this is the graph here between the temperature difference of the water and the surrounding, and this is the time. So, from the graph it is clear that, and it is the variation, from the variation it is clear that in the starting slope of this, that is delta upon delta t, is larger. But as the time increases, this slope also decreases. So, with the help of this graph, Newton's concluded that, and or you can say with the help of this experiment, he gave a law, and that law states that according to the Newton's law of cooling, the rate of loss of heat of the body is directly proportional to the difference of temperature of the body and surroundings. Now see here, let a body of mass m whose specific heat is given to you S and temperature at any time is T. And if it is cooling here, so we can write here dq upon dt is proportional to T minus T naught, where T naught is the temperature of the surrounding and T is greater than T naught. We can also write here in this case minus dq upon dt is equal to k and T minus T naught, where this k is here positive constant, that is a proportionality constant. We can also write here q is equal to mst. So, here we can written minus d upon dt mst is equal to k into T minus T naught. T is the temperature of the body for an instant we have taken. So, we can write here minus dt upon dt is equal to k upon m into s T minus T naught. So, now see here minus dt upon dt is equal to k upon ms T minus T naught. Again this is a constant here. So, we can write minus dt upon dt is proportional to T minus T naught. So, from here again you can conclude that here. So, or you can say according to Newton's law of cooling, the rate of fall of temperature is directly proportional to the temperature difference between the body and the surrounding. But see here, the temperature difference should not be more than 40 degree Celsius. Now see here, a body cools from 80 degree Celsius to 50 degree Celsius in 5 minutes. Calculate the time it takes to cool from 60 degree Celsius to 30 degree Celsius. The temperature of surrounding is 20 degree Celsius. So, you can write T naught is equal to 20 degree Celsius. You know this formula dt upon dt is equal to some constant we can put here T minus T naught. Change in temperature, this dt can be written 80 to 50. I am taking the first condition. So, that is case 1 we can take. So, 80 minus 50, that is 30, divided by time is here 5 minutes. So, we can write 5 is equal to k into, now this is T. T we can get here 80 plus 50 divided by 2. I am not using the integration process, so we can take average temperature. That is 130 divided by 2, that is 65. So, 65 minus 20. Similarly, in case 2 we can write temperature is changing 60 to 30 degrees Celsius. So, we can write again 30 divided by 5. So, not 5, we have to find this time. So, we can write here time here T is equal to k into, this is 60 plus 30, 90 divided by 2, that is here 45 minus 20. If you divide these two, you will be getting this and this equation. So, here 30 by 5 divided by 30 by T is equal to, this is here 45 divided by here 25. Now, this will get cancelled. So, here you will be getting T is equal to 45 into 5 divided by 25. So, 5 and this is here 9. So, you can write T is equal to 9 minutes. See here, this can be also done by integration process. Then you will have to take here the value of the log. So, no need to do that here, you can just do by taking the average temperature.